Hi everyone, let's work through a few examples of how to express a polar point in terms of r and theta as its rectangular equivalent in terms of x and y. So there's two formulas you're going to need to know to do this. The first is that the x coordinate is going to be equal to the r value in the polar point times the cosine of the angle. Now remember, in a polar point, as in this example we're going to look at first, 2 would be r, and theta would be our pi value. The other equation is that the y value is equal to r times the sine of the angle theta. So if we were to plot this polar point first, just to get an idea of what it would look like, remember we look at the angle first, so that would be over on the left at pi, and we're going to go 2 units out from the pole, so that would put us right about there. So as we calculate the x value, it's going to be equal to 2 times the cosine of pi. You got a lot of great practice in recalling all your unit circle values with this. Remember, cosine of pi is -1, so that gives us an x value of -2. The y value is going to be equal to 2 times the sine of pi. Sine of pi is equal to 0. So we have a y value of 0. So that means our rectangular point in terms of x and y would be the point -2, 0. So think about that. It kind of makes sense. We know where the point -2, 0 would lie on the Cartesian plane over on the negative side of the x-axis, which is, in terms of the polar graph, pretty much in the same location. So it does make a lot of sense. Let's take a look at another example. Here we have the polar point -3, 2 pi over 3. So the x value is going to be equal to -3 times the cosine of 2 pi over 3. Recall that the cosine of 2 pi over 3 is -1/2. So that gives us an x value in the end of 3/2. The y value would be -3 times the sine of 2 pi over 3, which would be -3 times square root of 3 over 2. So we have a y value of -3√3 over 2. If we were to plot this polar point, remember we start with the angle, 2 pi over 3, but because we have a negative r value, remember that means we slide it diagonally to the opposite side of the pole. So that puts us, and if we think about the coordinate plane and that rectangular point, if we were to plot that, remember, this point would have been in quadrant 4. Well, if you think about a rectangular Cartesian graph imposed on top of the polar plane, looks like about quadrant 4. Again, makes a lot of sense. So our last example, we're going to look at the polar point √3 pi over 6. So our x coordinate is going to be given by square root of 3 times the cosine of pi over 6. Cosine of pi over 6, remember, is square root of 3 over 2. So multiplying those, we get 3 over 2. Our y value is going to be √3 times the sine of pi over 6. Sine of pi over 6 is 1/2. So our resulting rectangular point is 3/2 square root of 3 over 2. Again, if we were to plot the polar point, we'd start at the angle, pi over 6. Square root of 3 for our r value is about 1.732, so almost 2 circles out from the center. So maybe around there. And if we were to think about plotting the rectangular point we got, that point ended up with in the end would be in quadrant 1, which again looks like where our polar point would be. That's one thing I love about polar points and rectangular points. They really do make a lot of sense in terms of how they relate to each other. So hopefully these 3 examples will enable you to move forward and do several of the others on your own.